Hello everyone, welcome to our another video in the series on mastering data structures and algorithms. Today we'll be talking about how to perform deletions from the linked list. Deletion means removing one or more nodes from the linked list. So let's begin. I'm Dr. Prashant K. Gupta. There's a link to my website. Apart from other information like my research publications, my patents, information about my international visits and other things, you'll also find the PPTs to the lectures that I'm delivering in these videos, as well as the C programming and Python codes for these practicals. So let's see. Whenever we have to perform deletion from a linked list, these following cases may arise. Case 1 pertains to whenever I have to delete a node from the beginning of the linked list. That is, the list from which the node needs to be deleted is the first node. List may or may not be empty. We'll see both these cases. Now, case number 2 may arise when we have to perform the deletion from a specific location. Specific location includes either the deletion from the node or at a position other than the first node, even including the deletion from the last node, and it does not really matter whether the list is sorted or unsorted. We'll see how to incorporate all these changes into the programming part. And case number 3 arises when the deletion needs to perform based on the data item value. Now, in this case, we are not given the position at which the data item occurs. We have to search through the linked list and find out the position of the data item. And again, over here, the list may be sorted or unsorted. We'll see all these cases. Let's see. The topic of this video is case number 1 when the deletion needs to perform from the beginning of the linked list. That is, every time a node is deleted is always the first node from the linked list. We have called our procedure as delete begin, and I'm passing two values, start and temp. Start is the address of the first node in the linked list, or called the header node, and temp is a temporary pointer that will be holding the address of the node that will be deleted. So our algorithm is very simple. We first of all compare if the start value is null. If it is null, so list is definitely empty, and we print the message that list is empty, and we exit out of the program. Else, we initialize the value of start to the we initialize the value and assign the starts value to the temporary variable temp. Then we increment the start to point to the next node in the linked list, that is the second node. In this way, we are progressing one node further, and then we free the memory allocated to temp, that was the value memory allocated to the first node. So let's see, like over here, as you can see, this is our linked list that we are given to us. Now it has the information like info1 in the first node, info2 in the second node, and so on till the last node it has the value info. Now, as you can clearly see, the start value is not null because our list is not empty. Therefore, this line will not be printed. So the control directly jumps to the else part. You can see. And over here, this first statement is executed. And the result of executing this first statement is the allocation of the address of the first node, that is starts value, to the temporary variable, that is temp. Temporary variable, or rather you can say temporary pointer, that is of the type of struct node. Now, as soon as we go for the allocation of value of start to the start link, so you can see now earlier start value which pointed to info1, that is the address of the first node. Now that link is broken. I have shown it by dash line over here, and this new link is established between the start node and the second node in the list. That's why I have shown over here by the arrow. Now the execution takes place, and we run the free temp to allocate to free up the memory that was allocated earlier to the first node. So in this way, first node is deleted from the linked list, or from the deletion is taken place from the beginning of the linked list. So this is straightforward conversion to the C program. These are the declaration of the header files. This is the declaration of the structure pertaining to the linked list. Inside our main function, we have two pointers, start and temp of the type of struct node, and we check if start value is null. So if start value is null, so we go for the printing of the message that list is empty. In the else part, we allocate the address of start to the temp, and then we increment the value of start to point to the next node in the linked list, and then we free up the memory allocated to the temp. So this is how we can delete a node every time from the beginning of the linked list. This algorithm can be run repeatedly to delete n number of nodes from the linked list till the time linked list becomes empty. Thank you for watching this video, and don't forget to subscribe to our channel. More and more good videos will be coming up soon. Thank you.